Welcome back to calculus. Well, this will probably be the last arc example, the two arc examples we're going to do. So we've seen by now the first thing we do is take the derivative, and look what we have here. Natural logs, trig, expressions. This one's actually very short. So, well, moderately short. Not as tedious, certainly, as the last one. So the derivative of natural log sine x, remember what that is? You take a derivative with natural log, you toss the thing being natural log to the denominator, and up top you write the derivative of the thing in the natural log, and that does become cotangent. Let's write it. You might wonder if we should, but let's do it. So our arc length is from pi over 4, the lower bound, to 3 pi over 4 upper bound, square root 1 plus cotangent x all squared. That's weird. And hopefully that rings a bell for you. What is, cotangent squared x? You might recognize it more like this: 1 plus cotangent squared x. That's a Pythagorean identity. It's equal to cosecant squared x. Hey, we can replace that. So we have the same bounds, but now we just have cosecant squared x. Do we know the integral of cosecant squared x? We do, of course. The integral of cosecant squared x, oh, sorry, I got that wrong. Do we know the integral of cosecant squared x? No. But it's under a square root anyway, so we're happy about that. We're going to make this cosecant x dx. So we simplified it. We got rid of the square root. That was the main thing. This is an integral I'd like you to know. It's negative. It's got the although cotangent is not negative, but it's negative. It's got a natural log, and it's got the sum of the Pythagorean buddies, cosecant x plus cotangent x. And that's evaluated from pi over 4 to 3 pi over 4. We have not changed any bounds. Okay. Again, this plug-in step, you might just want to fast forward. That negative is really annoying. So we have cosecant of 3 pi over 4 plus cotangent of 3 pi over 4. And then, I should leave that in there. This will be a minus the natural log of cosecant of pi over 4 minus cotangent plus cotangent of pi over 4. So I could distribute this negative to get rid of that, and it would be negative natural log of these. Who knows what these are, right? Well, this is the same thing as 1 over sine 3 pi over 4. This is the same thing as 1 over tangent of 3 pi over 4. If I do this, it's going to be a plus now. The same thing as 1 over sine pi over 4 and 1 over tangent pi over 4. Hopefully you remember what these are. The first one, we have sine of 3 pi over 4. It's positive, and it is square root of 2 over 2, so it's 1 over square root of 2 over 2, plus 1 over negative 1. This is also square root of 2 over 2. And this is positive 1. Well, the reciprocal of square root of 2 over 2 is square root of 2. Check that if you want. So you can divide something by square root of 2 over 2. It's the same thing as the reciprocal of that, which would be, and is multiplying by the reciprocal, which then you rationalize the denominator, You get 2 square root of 2 over 2. You get square root of 2. This becomes minus 1 plus, same thing over here. And then, you know, when you have two natural logs, let's just do this. Let's take this guy so you can see it better. I'm just going to move him over here. Two natural logs in a subtraction relationship, you can combine them into one. And so we end up with this. Make sure I got it right. Yes. Square root of 2 plus 1 over square root of 2 minus 1. By the way, we know square root of 2 plus 1 is positive. We know square root of 2 minus 1 is positive. We don't have to worry about the absolute values. And that is it. So much for being a short one. Sorry about that. And the final one for this section is going to be one page, I think this actually is page 473, number 19. And they tell you, here's the problem. They give you y equals 1 over x. Looking at this curve, find the length from 1 to 3. Just get the derivative right away. So derivative would be the same thing as x to negative 1. So it's negative x to negative 2, or negative 1 over x squared. Okay, this one is not going to be one we can integrate it on our own, so we're going to use our calculator. But they want us to do a few things. They said, set it up first, show a graph of what you're working with. So that's what 1 over x looks like. And we're looking at the length from 1 to 3. Which is that length right there. Not a straight line, so that's why I have to do these integration techniques. B says set up the integral. Well, the integral would be from 1 to 3, square root of 1 plus that squared. Well, I want to just do a little simplifying. You'll kind of see where our problem is. We get to that. What are you going to do? I mean, yeah, you can get a common denominator, but you're going to have a quotient. Can't integrate. There's no quotient rule for integrals. We'd be stuck. So we go to our calculator, and we evaluate in the calculator. You should get 2.417. We're not really doing units. So we'll see a couple of those that just let you use the power of the calculator to get an approximation. So that is surface area. So that's arc length. Surface area is up next. It's not very long, considerably shorter than this. I'm not going to prove the formula,